Hi everyone, welcome to the second of 3 lecture videos. In this video, we will introduce some of the commonly used tools in GIS as well as their applications in terms of community forest monitoring in Liberia. Along with this lecture video, we will also be doing 2 exercises using the vector and raster datasets that you imported into QGIS in exercise 1. We will also be learning how to create shapefiles. Creating shapefiles can be useful for a variety of purposes, including creating plots, transects, and modules for the repelled system. And so here's an overview of some of the learning goals for this video. We want to gain an understanding of commonly used GIS tools, along with how to create shapefiles in QGIS. We're also going to look at the open source part of the QGIS and something called plugins. And so maps are much more than what is where. Maps are more than just interesting colors and shapes that tell you something about location. This is where geospatial analysis comes in. GIS, or Geographic Information Systems, allows us to analyze many different types of data in a spatial context. One extremely important and useful part of most GIS software is the attribute table. Information exists or can be linked to most geographic features. The easiest way to display this information is usually in tables or in tabular form. Attribute tables allow you to visualize and analyze quantitative data. Another important aspect of attribute tables is the ability to logically query, search, or select for data that fits specific criteria. And like most tables, they're made up of rows and columns, and that all rows have the same columns in most GIS software. The attribute information for different types of data also varies. Attribute tables are an important part of all vector data, but are only really applicable to raster data if the data is categorical. For example, a continuous raster dataset would mean a separate row for each individual pixel, resulting in impossibly large tables. Raster datasets can usually only also contain one value of datum, while a vector shapefile, even a single point, can contain many various types of information. So, in summary, attribute tables are a lot more important for vector data than they are for raster data. Now, as I previously mentioned, queries are one of the primary benefits of attribute tables in GIS. Using queries, you could choose a subset of your entire database based on logical operators. These can be based on the attributes in the table or the geographic location of the shapefiles. However, for raster data, queries are very limited in terms of functionality. In fact, in QGIS, there isn't even an option for a raster layer to have an attribute table, although that's not true for all GIS software. And this is one of the problems in QGIS that we will explore further in our exercise. Okay, so moving on, we will go over some of the most commonly used tools in GIS. The first one of which is the buffer tool. So the buffer tool is a proximity function that creates a polygon at specific distances surrounding the input feature. And the buffer tool was a big part of the fragmentation analysis done on community forests in Liberia. The figure you see here is a 1 kilometer buffer around the Matro community forest in Liberia. With the buffer, we could then compare land cover and other fragmentation metrics inside and outside within the 1 kilometer buffer. And we will do a similar analysis as part of our exercise in the next video. Another very commonly used GIS tool is Clip. For this tool, you need 2 input files, an input and a clip feature. The tool will extract the input feature based on the extent of the clip feature. As the figure shows, the clip creates a new layer that is only within the extent of the defined clip feature boundary. Now there are various different clip tools with slightly different names in different GIS software. Some of these clip vector data, while others clip raster data. Next, we have the difference tool. This tool takes the difference between 2 input shapefiles. This tool is also called erase in ArcGIS because it erases smaller shapes from the bigger shape to create a donut shape. The merge tool also creates a new output shapefile, but this time it adds and merges 2 input files. Merge can only be done with data of the same type. And lastly, you can manually create shapefiles, points, lines, and polygons in GIS. This is not really a tool and more of a functionality in GIS programs. Creating polygons, lines, or points can be a very versatile thing to do. For example, you could use it to digitize features that haven't been digitally mapped yet, or you could create a shapefile to help you in your analysis, such as creating a shape with the size and area that you control that you want to erase or use the difference tool on. And so these are some of the basic but commonly used tools and analysis methods in QGIS. Now the base software of QGIS has most of these tools built in. However, it doesn't have everything, especially if your analysis is a bit more advanced. But the good news is that QGIS is an open source software. This means that anyone can go in and write their own code and create their own analysis tools. In QGIS, these created tools come in what's called a plugin. Not all of these plugins are good and useful, but QGIS reviews most of these plugins and rates them as trusted or non-trusted. We're going to briefly explore plugins in exercise 2. Now here are some examples of potentially useful QGIS plugins. GPS tools, which helps deal with importing and modifying data from field GPSs. F tools, which builds on top of the pre-existing vector analysis tools. And Open Layers, which allows you to bring in maps from Google Earth, Google Maps, Bing Maps, and so on. And that concludes our second lecture video. I'd like to end with this, which is a compiled list of many really good sources of data that we have found. In our next video, we will do 2 short exercises where we explore some of the QGIS tools and procedures from this lecture.